Just joking. All right. So this thing is called butane. All right. It's a fuel, just like propane. It's what we call a hydrocarbon. It's made of just hydrogens and carbons all together. Kind of goes in the whole gasoline-like family. Yes, it's dangerous in short. Mark, please don't be causing problems over there, please. No. Thank you. All right. All right. So I'm so glad you guys like fire. All right. So as you can see, we've talked about this before. You got the two different flames there. The different colors meaning what?
How hot it is?
Yeah, different temperatures. All right. So when we when we burn things, well, let me first ask you this question: why does something burn?
Because it's flammable.
Oh, raise your hands.
It's hot.
Yes, sir.
Flammable.
No, not necessarily that.
Oh wait.
But why is there a flame?
Because
You
of
can
its
sit with
chem-
Kyle. Hold on. David?
Because the chemicals in it, when it gets dehydrated, it's flammable.
Well, let me ask you this. If I was up in outer space, would I be able to do that?
No, there's no
Okay,
oxygen.
okay. Please, again, raise your hand.
I'm sorry.
All right, Ezekiel?
No.
Because fire feeds on it.
Okay, yes, okay. So, it needs oxygen to be able to create a flame. All right? You need oxygen. All right? So when we talk about oxygen, we're talking about a reaction with oxygen. So when you get a flame, okay, it's because that flame is being fed with oxygen. Like rust on a car, okay? It's the iron in the metal that's reacting with oxygen, all right? This butane is creating a flame because it's reacting with oxygen. But let me ask you this. The stuff that's burning off, is it butane?
No.
No, it's not, all right? This stuff that burns off of here, is it wood?
No.
No, it's not, all right? All right, so oxidation would go under which category? Chemical. So when we're talking about a chemical change, we're talking about an actual change in what the material is, okay? So when we talk about chemical properties, we're talking about the way it reacts to change what it is, okay? So if it reacts with oxygen, it's going to change the substance, okay? All right, so oxygen goes in the chemical property category. All right, talking about malleability. I'm going to turn that off so I'm in trouble. All right, this is a property of metals, okay? So I have up here some fabulous, wonderful copper wiring, which we're going to have lots of fun with today. Copper wiring, all right? Demo, let's see, come here, Josh. You need to hurry, Josh. Josh, you need to hurry.
Isn't copper like a lot of money?
All right, Josh. All right, so I'm going to give, okay, so Josh, I'm going to give that to you, and I want you to make a shape out of it. Here, give me your phone, and I will do it. All right. Oh, that's very cute. All right. Thank you, Josh. All right, Dominique, come on up here. All right. I'm going to give you the same piece of wire, and I want you to change it into a different shape, please. Star. Josh, that's not what you're supposed to be doing.
Make it into.
Hey, John. Oh my God.
All right, we turn it into a blob. All right, thank you. Okay, so not the original shape, but let me ask you guys this. Did you change what this thing was?
No.
No, you just changed its physical appearance, okay? So, malleability is the ability to change metals by its shape, okay? So change the shape of metals, okay? By bending it or folding it or whatever needs to be done, all right? So this would be a physical property. You're changing its outward appearance. You're not changing what it is. Because again, have I changed any part of this at all into something else?
No.
Okay, so physical. All right. Conductivity, you guys talked a little bit about yesterday, all right? You got these things, you hooked it up to a battery, da-da-da-da-da. Okay, again, another property of metals and non-metals, okay? So, ooh, wow, was I just checked myself? It's okay, it happens. Okay, so, again, turns on the light, all right? You guys put it in some salt water, all right? turns on the light. Yay, yay for that. All right, but if I were to attach this to say something else like, let's bring out the copper wiring again, without trying to shock myself here. All right, so if I touch these two together, what should happen?
It's like,
All right, so it turns on, lights up, fabulous. All right. So when we talk about conductivity, we're talking about the ability to transfer energy, because we're gonna have a little bit of fun with this again, and I'm gonna see if I can not burn myself this time. All right. Yes, I did. Yeah, I have like a first-degree burn on my hand right about now. Not purposely. All right. All right, so I'm just going to put this in here for just a second. Okay. Again, it's metal. What happens when metal gets heated?
or it like contracts the heat so it gets hotter.
All right, so even though this part's in the flame, what's going to happen to the rest of this?
It's gonna get hotter. Well, it's gonna.
Yeah, and it is. All right, so, okay, because, again, metals are conductors of heat, but let me ask you this. Did I change what this is?
No.
No. All right, so conductivity goes under which one? Physical. Ah, it's a physical property. All right. We're going to get to the boiling point one here in a moment, but because I forgot to plug it in. Sorry. All right, but boiling. You're going from a liquid state to a gas state. All right, and here I have liquid water. When it becomes heated, what happens?
It boils and turns into mist.
Evaporates.
It evaporates and it turns into,
Steam.
well, what is steam?
Evaporated.
Okay, water vapor. All right, so we're going from water, liquid H2O to gas H2O. Have I changed what it is?
No. Well,
No.
yes. Yes, you.
Have I actually? I have.
Well,
Is
I'm
it
just gonna
still
hold it.
H2O?
yes.
It is still water. Okay, so boiling point would go under which one?
Physical.
All right, so when we talk about changes in states of matter, that's a physical change. You're just changing its state. It's still water. It's still H2O.
Where does it go?
It's physical. Okay. All right, let's talk about color. Color's a fun one. All right. So if I add, a little bit of food coloring here, so I'm not changing the color, and I just missed it. Oh, all right. So, and if I asked you to drink it, which I'm not going to though, what would it taste like? It's
Water.
still water. It's still H2O. It just has a different color to it now. All right. So color would go under physical. Physical. Yes, it's physical.
Isn't food coloring poisonous?
It depends on the quantity, and some people are allergic to certain food dyes. All right. All right, density. You guys have talked about density many, many times before. Yes.
Yes.
All right. It's the ratio of mass to volume, right? The more mass there is in a given volume, the denser an object is. All right. So, okay, in here, got some water. All right. Take a little bit of vegetable oil. All right, get some vegetable oil up in there. All right, add a little bit of
Vinegar.
rubbing alcohol. Relax, I'm not gonna relax. What?
Vinegar smells good.
I'll let those kind of settle there a little bit. All right, density.
Vinegar.
All right, density is what allows the oil to float on top of the water. Well, that's part of it. All right, and then eventually the alcohol will sit on top of the oil, and you get this nice little column of stuff here. But did I change what anything is?
No.
All right, so density would be
Physical.
physical. That's a physical.
Oh, Ms. Rock, can I give an example of density? Oh wait. So if you get like a bottle of like a cup of water, right?
Uh-huh.
And you put grape on it, like grape juice in it,
Uh-huh.
like all the grape juice will go all the way to the top. Like if you leave it in there for like a couple minutes.
Correct. They will actually separate. All right.
No, the grape juice will go on the bottom
Great.
because it's more heavy or whatever.
That's right. It's a slightly. I don't know. I had to test it.
Yeah, I done.
Okay. Bring me a picture of it or something. All right. All right. Next one. Odor. All right. I'm going to forewarn you guys. This is strong. I'm not telling you.
It's a vinegar.
All right. Before I even give it to you, what's the proper way of smelling? Wafting. Oh, I love your wafting motions class. All right. So make sure the lid travels with it. To smell it though, you do have to take off the lid. All right. As my other two classes did not figure out. All right. So, Kaya. All right.
Kaya, take off the lid and leave it on.
All right. Guys, can you pause your videos for just 1 second, please? Pause it.